Hello students. In the previous class we discussed atomic mass, molecular mass, Avogadro number, a brief introduction to mole. Today we are extending the mole concept with numericals. Okay, before that we should know a preliminary idea about prefixes. What is the meaning of prefixes? Certain quantities, especially physical quantities, may be very big, may be very small. To express these physical quantities through a prefixes, it is very easy for calculation. For example, most commonly we use centimeter, millimeter, picometer, nanometer. Meter is a unit for a length in the SI system, but pico, nano, deci, centi, what all these? These are all prefixes used in day-to-day life, especially in the science. Some of the most common prefixes we will come across, which are as follows. Let us take from 10 to the power minus 15. 10 to the power minus 15 means it is a very small number. It is said to be femto, symbolically small letter f. 10 to the power minus 12 is said to be pico, small letter p. 10 to the power minus 9 is nano, small letter n. 10 to the power minus 6 is micro, this is mu. 10 to the power minus 3 is milli, small letter m. 10 to the power minus 2 is centi, small letter c. 10 to the power minus 1 is deci, small letter d. These are very small numbers. 0.1. 0.1 is nothing but 10 to the power minus 1. If it is a meter, 10 to the power minus 1 meter can be written decimeter. 10 to the power minus 2, 0.01 is centi. Instead of 10 to the power minus 2, we can write cm, centimeter. So like this, it is very helpful in the calculation. Small number 0.000009, 0.000001, 0.00001. These are a small number. It is very difficult to manage for calculation. So we are using these prefixes. So deca means 10 to the power 1 is deca, 10 to the power 2 is hecto, 10 to the power 3 kilo. Suppose if you are using a kilo, no need to write 10 to the power 3 again. If you are writing 10 to the power 3 grams, 10 to the power 3, 10 to the power 1, no need to write h or k again and again. Either we use the multiples of 10 or the symbols. Both should not be used as such. 10 to the power 6 means mega. 10 to the power 9 means giga. 10 to the power 12 means tera. 10 to the power 15 means peta. 10 to the power 18 is hexa. 10 to the power 21 is zeta. 10 to the power 24 is iota. This is a very big number. For example, 1 kg. 1 kg means what? 1 kilogram. 1 kilogram can be written 10 to the power. Kilo means where it is here. 10 to the power 3 grams is there. 10 to the power 3 grams can be written kilogram. Why means 10 to the power 3 mean kilo. Symbol for kilo is small letter k and gram is written. That is the meaning. And 1 millimeter. What is the meaning of milli? Look here. Milli means 10 to the power 3. 10 to the power minus 3 meter, 10 to the power minus 3. What is 10 to the power minus 3? 10 to the power minus 3 is milli. The symbol is m, small letter m, meter. 10 to the power minus in the place, we are writing milli, and meter is written as such. So this is the use or application of the prefixes and symbols. This chart is very helpful. As I said in the last class, at least you should be familiar with minimum first to 30 elements, its a symbol, atomic mass and mass number. Okay, atomic number and mass number. Today we are discussing the concept mole and molar masses. As I said in the last class, mole is used to express the amount of substances. Symbolically, N. The unit for mole is MOL. Mole means it is an amount of substance which is expressed in terms of MOL, which is equal to 1 mole of substance. Substance I am using. Substance may be atom, molecules, or any particles. 1 mole is equal to 6.022 into 10 to the power 23 number. If it is an atom, 6.022 into 10 to the power 23 atoms. If it is a molecule, 6.022 into 10 to the power 23 molecules. If it is a particle, ions, Na plus, K plus, Cl minus, anything, which is equal to 6.022 into 10 to the power 23. This is the meaning of a mole of a substance. See, here some examples are given. 1 mole of oxygen atoms. Look here, oxygen atoms. Oxygen atom means not O2, O only. Oxygen molecule means O2. If I say 1 mole, it should go to your mind. It is equal to 6.022 into 10 to the power 23 atoms of oxygen. That number is called Avogadro number. It is written as Na. It is written as Na. And 1 mole of oxygen molecules are given. 1 mole of oxygen is nothing but you are taking O2, which consists of 6.022 into 10 to the power 23 molecules of oxygen. Molecules of oxygen. This is one. This is the meaning of a mole. It may be particle, it may be ion, it may be molecule, it may be atom, whatever it may be. That number should be equal to Avogadro number. Go to next topic. Gram molecular mass. What is the meaning of gram molecular mass? Gram molecular mass, which is equal to 1 gram molecule. What is the meaning of 1 gram molecule? 1 gram molecule, which is equal to 1 mole of the molecules. 1 mole of the molecule, which consists of 6.022 into 10 to the power 23 molecules. Let me take a small simple example. Gram molecular mass. This gram molecular mass is equal to 1 gram molecules. 1 gram molecule means you take oxygen. Oxygen O2, it is an atom or molecule? It is a molecule. Now, atomic mass is 16. 2 atoms are combined to give O2. What is the molecular mass? 32. If you take 32 grams, it is a gram molecular mass. This 32 grams, which is equal to 1 gram molecule, which consists of 6.022 into 10 to the power 23 molecules of oxygen. Now it is clear. If I ask you to take 1 mole of oxygen, how much you are taking? 32 grams. What is that 32? 32 is a molecular mass. You are expressing in terms of a gram, that is a gram molecular mass of oxygen. In the same way, okay, you take chlorine, Cl2. What is this? Chlorine is molecule. Cl2 means molecule. Cl is atom. Now, chlorine, what is the atomic mass of chlorine? In the last class we discussed. Atomic mass of chlorine. Just go through once. Where chlorine comes? Chlorine 17. Its atomic mass is 35.45. Its atomic mass. Now, it consists of two atoms, Cl and Cl. Now, 35.45 can be written 35.5, 35.5. Its atomic mass. You are expressing in a gram, so it is equal to 35.5 grams and 35.5. How much? Which is equal to 35 plus 35 is 70.5 is 71 gram. What is this 71 gram? It is a gram molecular mass of chlorine molecule. If you take 71 grams of a chlorine, which is equal to 1 mole. This 1 mole is equal to Avogadro number. This is conversion factor, very much required. Be careful and learn properly. Okay. Another example you take. Now, you take second example. H2O. I am taking very simple molecule H2O. First, you should know whether it is an atom or a molecule. H2O, it is a molecule. Why? Means it is made up of two different elements. One is oxygen and hydrogen. It is a molecule. It is not atom. It is clear. Okay. Now, being it is a molecule, what we should do? We should calculate its molecular mass. How to calculate? Very simple. H2O. First you write number of elements. One is hydrogen, another is oxygen. These are two elements. How many atoms of hydrogen? 2 atoms. How many atoms of oxygen? 1. What is the atomic mass of hydrogen? 1. What is the atomic mass of oxygen? 60. Now 2, 16, 18. This number what you got is molecular mass of water, that is 18. It's just mere number. Now if I write grams, 18 grams is a gram molecular mass of water. If you take 18 grams, which is equal to 1 mole, which consists of Avogadro number of molecules. 18 grams consists of Avogadro number of molecule, that is 6.022 into 10 to the power 23 molecules of water, which is equal to 1 mole. This is second example. Take one more example. I am taking a very simple molecules, carbon dioxide. First, whether it is an atom or a molecule, CO2 is a molecule. How many elements are there? two elements. First write down carbon, one element, oxygen, another element. How many atoms of carbon here? Look into the molecular formula. You will come to the number of atoms, one carbon atom. Number of atoms of oxygen, 2. Carbon. What is the atomic mass of a carbon? That is A12. What is atomic mass of oxygen? 16. That is 12, 32, which is equal to 44. 44 is a mere number. So if I write grams, it's a gram molecular mass of carbon dioxide. So if you take 44 grams of carbon dioxide, which is equal to 1 mole, which consists of Avogadro number. Avogadro number. This is second example. Let me take few more examples, then it will be easy. Take HCl. See, now you are using that atomic mass number you are using. If you are familiar, it is easy to solve. Otherwise, it is difficult. So, first same procedure we are following. It is a molecule. Write the element hydrogen. Another is chlorine. Only one hydrogen is there. Simply we can write 1. Chlorine 35.5. 35.5 HCl. 36.5 grams, gram molecular mass. If you take 36.5 grams of HCl, which is equal to 1 mole, which consists of Avogadro number. Avogadro number means 6.022 into 10 to the power 23 molecules of HCl. I hope you are familiar with a concept, a mole. So, if you want a mole of a substance, how much should be taken? Its gram atomic mass or gram molecular mass of a substance should be taken, which is equal to 1 mole. I have taken molecules. Is it applicable only for the molecule? No, you can take anything. It may be atom, ions, or any substance. Let us take another example, helium. Now tell me whether it is an atom or a molecule. Helium. He means helium is a gas, monoatomic. It does not combine with the other atom of helium like oxygen or nitrogen. It remains as such in an uncombined state. So it is an atom. If it is an atom, what should be taken? Gram molecular mass or gram atomic mass? Being it is an atom, we should consider its gram atomic mass. What is the atomic mass? You might be not knowing. Just look here. That's why I have given this chart. Helium. Atomic number is 2. Number is not required. Mass is required. Correspond to this, you can find the mass. That is 4. Now, here. So 4, I have written 4. 4 is atomic mass. 4 grams is gram atomic mass, which is equal to 1 mole, which consists of Avogadro number of particles. So this is how you can calculate how much mass is required to get a mole of a substance. So now we are discussing conversion of mole to mass to moles, and few other things will be discussed now. Okay, next, see, let us take a problem on this. Calculate mass of the following in grams. 0.25 moles of a copper. What they have given? First you take down the data. Given data is 0.25 moles of copper. See, they have given moles. What you should calculate? Mass of the following. So mass is equal to question mark. So whatever I discussed, conversion of mass into moles. Now the question is, they have given mass, how much? Moles is given, 0.2 moles of copper is given. You should calculate mass. Very simple. So which formula is applicable? Always it is difficult to convert, and making a numerical lengthy is worthless. So we can use the formula. How to calculate mass? Mass can be calculated. Mass of 0.25 moles of a copper. Very simple. Mass of substance. Mass of substance is equal to number of moles into gram atomic mass. Very simple formula. So they have given mole. How much? 0.25 moles. Gram atomic mass is not given. You should know. That's why I said to learn at least 30 elements. Here it is given 63.54 is a gram atomic mass of a carbon. That is 63.54. 63.54. Okay. 54. Now multiply. We get that is equal to 15.885. Being it's a gram atomic mass, we are writing 15.885 grams. So if you take 15.885 grams of copper, which is equal to 0.25 moles of a copper. This is one method. Suppose if you forget the formula, then how to solve? Very simple method. If you don't know the formula, this can be calculated very easily. Look here. We know the standard. 1 mole is equal to gram atomic mass of the substance. 1 mole is equal to gram atomic mass of the substance. Here, how much grams is given? How much moles given? 0.25 moles of copper is there. 0.25 moles of a copper is given. Its gram atomic mass is known. Wait. Easy method. If formula is not known, if you have forgotten that formula, easily we can calculate by using a standard method. Look here. Take 1 mole is equal to gram atomic mass. 1 mole is equal to gram atomic mass. So gram atomic mass is known. 1 mole of a copper, 1 mole of a copper, gram atomic mass of a copper is 63. You take for calculations are 63.54. If you take 63.54 grams of a copper, which is equal to 1 mole, how much is given? 0.5 moles. How many grams should be taken? How many grams should be taken? So we can calculate by this method, which is equal to 0.25 into 63.54 is equal to is equal to how much grams? So you will get the mass here. So gram atomic mass, if you take this much of a gram, which is equal to 0.25. This is another method to calculate if moles are given, how much mass should be taken. Let us take another example. See, 0.5 moles of water. They have given 0.5 moles. To get 0.5 moles, how much mass of water to be taken? How many grams of water to be taken? Very simple. Either you can use this formula. So, mass of 0.5 moles of hydrogen is equal to number of moles into gram molecular mass. Why gram molecular mass? Because we have taken water. 0.5 gram molecular mass is 18. If you multiply, you will get the value, that is grams of water. If you take 0.5 into 18 grams, that is equal to 0.55 or 0.5 moles of water. 0.5 moles of water. Take one more example. Which example? Okay, we take carbon dioxide. 0.3 moles. 0.3 moles of carbon dioxide is equal to how many grams? Or how much grams of carbon dioxide makes 0.3 moles? Both are same. Take standard. So, gram molecular mass is equal to 1 mole. What is the gram molecular mass of carbon dioxide? 44 grams. If you take 44 grams, which is equal to 1 mole. So, here how much mass is to be calculated, but they have given 0.3 moles. 0.3 moles. To get 0.3 moles, how much grams of carbon dioxide should be taken? Just cross multiply. Number of moles, how much? It should go here, 0.3 moles given. What is the gram molecular mass? 44 grams is equal to x grams. If you multiply this, you will get the value. This grams, if you take, which is equal to 0.3 moles. These are all very simple problems. See what you did here. First, you should listen carefully. So, you have converted moles into mass. Moles are given and it is converted into mass. So, which formula we can apply? Mass of a substance is equal to number of moles into gram atomic mass or gram molecular mass. So, this formula is applicable here. So, if you want to calculate mass, moles are given, this formula is applicable. Are you clear? Yes. Now, this can be extended further. What extension can be made? So, here mass is given, mass is a question, moles are given. Is it possible to convert number of particles into moles? Yes, we can convert. How? A very simple formula can be applied. Look here. 6.022 into 10 to the power 23 molecules, atoms or ions is equal to 1 mole, which is equal to gram atomic mass or gram molecular mass. Both are same. If it is an atom, gram atomic mass. If it is a molecule, gram molecular mass to be taken. See, if 6.022 into 10 to the power 23 atoms or a molecule is equal to 1 mole. Observe. I have given 6.022 into 10 to the power 22 atoms of oxygen. Atoms of oxygen. How many moles? How to calculate? Very simple calculation. 6.022 into 10 to the power 3 is equal to 1 mole. 6.022 into 10 to the power 23 is equal to how many moles? How many moles? So, if you cross multiply, see 22 into 10 to the power 22 divided by 6.022 into 10 to the power 23. This get cancelled. 10 to the power minus 1. 10 to the power minus 1 is 0.1. So what we did here? Here the number of particles, number of atoms are given. This number is converted into mole. This number is converted into mole. Now this can be extended further. So you got a mole. If I ask what is the mass of 6.022 into 10 to the power 22 atoms of oxygen. So mass directly it can be calculated, or by using this method we can calculate. So first what we should do, that number of particles should be converted into moles. Why? Means we have a relation. What is that relation? Mass of a substance is equal to number of moles into gram atomic mass or gram molecular mass. If you know the number of moles, we can convert into mass. That's why it is converted. Okay. If they give only how many moles, we can stop it here. If it is extended further, mass is asked, we can calculate by using this formula. Number of moles 0.1. What is a gram atomic mass? Being it is an oxygen atom, gram atomic mass is 16. You multiply, you will get the value 0.1 into 16 gram. So this is how we can convert moles into mass, number of particles into moles, further moles into mass. These are all interconversions. So this you should learn properly. Okay, I hope this is clear. This is clear. Okay. So this is one example. It is mentioned here, but I saw many examples. Now, second one. Calculate the mass of the following. Mass of the following. You should be very careful about the question. Especially in this topic, mass, moles, numbers, gram atomic mass, gram molecular mass, mass of one molecule. See, mass of molecular mass is different, mass of one molecule is different. What is the mass of one molecule? Take an example. You have taken oranges, 1 kg oranges. Out of 1 kg orange, 1 kg oranges mean you might have get 10 numbers. Being it is a similar type of molecule, mass should remain same in this case, but not in the case of orange. Don't compare as such. So 10 oranges are there. 10 oranges makes 1 kg. So if I ask what is the mass of one orange, what you are doing? Total mass divided by number of oranges. What is the total mass? 1 kg. 1 kg is equal to 1000 grams. 1000 grams, number of oranges 10. So it is equal to 100 grams. You are telling 100 grams. It may be 100, so if it is a small, it may be less, but not in the case of molecule. It should be the same. Then how to calculate? So that we are discussing now. So what we are doing? So calculate the mass of the following. 1 molecule of urea. 1 molecule of urea. See, you might be not knowing the formula. I will teach you. They won't give CO2, NO2, SO2, HNO3, HCl. If it is given directly we will calculate. H means hydrogen 1, chlorine is 35.5, you are adding 36.5 is HCl. But here urea is given. If name is given, you should be familiar with molecular formula. Urea, what is the molecular formula of urea? See, NH2 CONH2. If you know the molecular formula, you can calculate molecular mass. As I taught you in the beginning, first you are writing the elements: nitrogen, hydrogen, carbon, oxygen. First take nitrogen, 1, 2, 2 nitrogen. Its atomic mass is, nitrogen number is 7, it is 40. Hydrogen, 2 plus 2 is equal to 4 into 1. Carbon, 1 carbon into 12. Oxygen, 1 into 16 is 28, 4, 12, 16. If you sum up, which is equal to 60. Actually, you should be familiar with the molecular masses also. Some of the common molecules, compounds are given, its molecular mass should be known. So in the NEET, CET and JEE, you may not get sufficient time to calculate. If you are known molecular mass is 60, in a simple steps you can calculate the problem, the question very easily. Okay, because being it is a first class, you are in the learning process, I am writing each and every step, but you should be familiar with this, so you can skip all these steps and the answer can be obtained within 1 or 2 steps. Fine. So you got molecular mass, that is gram molecular mass is 60 grams. Fine. What is the question here? You should calculate mass of one molecule. Mass of one molecule. So how to calculate? We know that if you take 60 grams, which is equal to 1 mole, which is equal to 6.022 into 10 to the power 23 atoms. 23 atoms. If you take 60 grams, it is giving 6.022 into 10 to the power 23 molecules of urea. What is the mass of one molecule? So, one molecule mass is equal to how much is the question. Now, see, cross multiply. So 60 grams, 6.022 into 10 to the power 23 molecules. If you take this much, it is 60 grams. What is the mass of one molecule? What is the mass of one molecule? So molecular side is this one. How much grams is the question. So it is very simple. So 60 grams divided by, it is downside, 6.022 into 10 to the power 23, which is equal to 9.96 into 10 to the power minus 23 gram. Mass of one molecule of urea is 9.96 into 10 to the power minus 23 gram. So this is the meaning of mass of one molecule. Mass of one molecule. Let us take another example. Mass of one molecule of water. Now tell me how to calculate. Very simple. Mass of one molecule of, if it comes to the molecule, it should be clear, that is Avogadro number. Okay, so if you take 18 grams, what is 18 gram molecular mass of water? 18 grams, which is equal to 6.022 into 10 to the power 23 molecules. Then how much mass is given by one molecule? What is the mass of one molecule is a question. So same like that, that is 18 divided by 6.022 into 10 to the power 23 molecule. If you calculate, you will get the value. So is it possible to make it into formula? Yes. If you want to calculate mass of one molecule or atom, if it's an atom, we should take, what is this number? 18 is a gram molecular mass. Gram molecular mass or gram atomic mass. If it's an atom, you are taking gram atomic mass divided by 6.022. 6.022 into 10 to the power 23. So this formula can be used to calculate mass of one atom, mass of one molecule, this formula. So this is the second formula what we learned today, which is the first. If number of moles are given, we can calculate the mass. How? Mass is equal to number of moles into gram atomic mass or gram molecular mass. Second one, mass of one molecule or one atom, which is equal to gram molecular mass or gram atomic mass divided by 6.022 into 10 to the power 23. Use this formula, substitute, and you will get the answer. No need to follow this step. Being you are learning, so you also use this method. So if you know the formula, in a simple way we can calculate. Okay, and one more example, it is given molecular mass of sulfur dioxide is 64. So molecular mass of sulfur dioxide is 64. What is the mass of one molecule of sulfur dioxide? Very simple. So use this formula, gram molecular mass. What is the gram molecular mass? 64. 64, right? Gram molecular mass is 64 divided by Avogadro number 6.022 into 10 to the power 23 is equal to 1.06 into 10 to the power minus 22 grams. So in a simple way it can be calculated. Okay, that is first formula and second formula. Okay, now we are discussing another question. So if you are solving more and more number of problems on this chapter will be very easy. No need to by heart. Simply you are applying the formulas and you are using the concept, so we can get answer very easily. No difficult on any of this part. Fine. Now let us take another question. Calculate number of moles containing. So in the first part they have given moles, you have converted into mass. In the second part you have calculated mass of one molecule. Here the question is different. Calculate number of moles. What data is given? So number of moles containing, first question is 1.8 into 10 to the power 24 molecules of carbon dioxide. First, we should read question carefully. What is given? What we should solve? This is the data given. So, they have given 1.8 into 10 to the power 24 molecules. What you should do? It should be converted into number of moles. Very simple. So, which formula to use or to be used to calculate number of moles? So if molecules number given, so we have a formula. See, number of moles is equal to number of molecules divided by 6.022 into 10 to the power 23. Okay, we used this formula already. Okay, number of moles is question mark. They have given number of molecules. How much? 1.8 into 10 to the power 24. 6.022 into 10 to the power 23. So this is, you take to numerator which is equal to 6 and 18. If you consider it is a 6 and 18, 6 3s are 18, it is almost equal. 10 to the power 23 means it is equal to 10 to the power 1. 10 to the power 1 is a 10, so it is a 6. 1.8 is 0.3. It can be written approximately 3 moles, or if you want to calculate, which is equal to 2.99. So what we did here, so number of molecules are converted into number of moles. How to convert number of molecules into moles? Number of moles is equal to number of molecules into Avogadro number, So if they ask number of molecules, if moles are given, yes, we can calculate by using the same formula. So number of moles into Avogadro number, which is equal to number of molecules. We reframed the formula to calculate number of molecules. If moles given, you can convert it to number of molecules. If number of molecules given, it can be converted into moles. This is the third formula. You should learn properly. This is the third one. Okay, finish. So let us take one more example. 1.204 into 10 to the power 23 atoms of sodium. Okay, so number of moles should be calculated. Which is the formula? Number of moles is equal to, here atoms are given, number of atoms divided by Avogadro number. How many atoms given? 1.204 into 10 to the power 23. Avogadro number 6.022 into 10 to the power 23, which is equal to 0.2, almost 0.2. This can be written 0.2 moles. So this is how we can convert number of particles into moles. Okay. Let us take one more question. Number of moles of 6.022 into 10 to the power 22 molecules of water. Molecules of water. So number of moles, you have 6.022 into 10 to the power 23 molecules of water. This number of molecules makes how many moles? Which is a formula? Same formula. Number of moles is equal to number of moles is equal to number of molecules divided by Avogadro number. How many molecules given? 6.022 into 10 to the power 22 divided by 6.022 into 10 to the power 23. So 10 to the power 22 minus 10 to the power 23. So this is minus 23. 0 minus 1 is 0.1 mole. 0.1 mole. So this is how we can calculate number of molecules, number of atoms into moles. Okay. Next is atomic mass. In the yesterday's class I discussed, just I ask you to remember atomic mass using that chart. The 30 elements are given. So it's mass number, symbol and atomic mass. What is the meaning of atomic mass? So I gave a brief idea about atomic mass, gram atomic mass and mass number in the last class, and atomic mass unit. So today we are discussing in detail about atomic mass. So what is the meaning of atomic mass? Atomic mass is defined as ratio of average mass of an atom of an element to 1/12 mass of carbon-12 isotope. We should recall two things here. One is average mass, another is 1/12 mass of carbon-12 isotope. In the last class I explained in brief. So this is written in terms of formula. Atomic mass is average mass of one atom of the element. What is the meaning of average mass? Average mass is applicable for the elements which exist in the isotopic form. So if I take hydrogen, three isotopes are there: hydrogen, protium and tritium. So these are the three isotopes. To take oxygen, we have isotopes. Carbon, we have isotope. Nitrogen, we have isotopes. Its abundance is also not 50-50%, equally not distributed. Its percentage abundance is to be considered and its mass is to be taken and average mass of an atom to be calculated. So in many of the cases we get decimal 1.009, 35.5, 28.38 because of the existence in the form of isotope. Therefore, average mass of an atom should be taken and 1/12 mass of carbon-12 isotope. So this is the definition for atomic mass. Atomic mass. Let us take carbon-12, as I said in the previous class, 1/12 mass of carbon-12 isotope. 1/12. Why you have selected? What is the purpose of taking 1/12? Why you have not taken 1/13, 1/6, 1/8? Because it is very simple. We are taking carbon. 12 means in the nucleus of a carbon we have two parts. Any atom we have two parts: protons and neutron. Protons are six, neutrons are 6. The total parts present in one nucleus of a carbon is 12. The mass of proton and neutron is almost same. So it is this is the reason why we are taking 1/12. So you take this part, or any part of your interest can be taken. This is a one part of that nucleus. So you are calculating one part of 12 numbers. This is a 1 by 12th mass of one atom of a carbon. You are comparing this mass with other. For example, you take nitrogen. Nitrogen atom consists of nucleus, right? So, what is its mass number? 14. 14 means this nucleus consists of 7, 1, 2, 3, 4, 5, 6. 7 protons. 1, 2, 3, 4, 5, 6, 7 neutrons. So, this also contain 7 protons and 7 neutron. Its number is 14. What is the meaning of this 14? This is 14 because the nucleus of nitrogen is 14 times heavier. 14 times heavier than 1 by 12th mass of carbon 12 isotope. So it is just like comparing this with the other. You know the mass of this. If I ask you what is the mass of the palm, 1, 2, 3, 4, 5 parts are there. Yeah, approximately will 10. It is 5 times heavier than this pencil or pen. 6 times heavier, 10 times heavier. So you are comparing the mass of unknown with the mass of known, hence it is relative mass. Actual mass we don't know. You are comparing with the others or a standard, it is considered to be relative. If I take oxygen atom, what is its mass number? What is the mass number of oxygen? It is 16. So 16 number, what it implies, it is 16 times heavier than 1 by 12th mass of carbon 12 isotope. This is the meaning of 14, 16, 8, 4. You take helium. What is the mass number of helium? It is a 4. What is the meaning of that 4? It is 4 times heavier than 1 by 12th mass of carbon 12 isotope. So this is about atomic mass. If you look into the features of atomic mass, what is it? Atomic mass, it is a mere number. Mere is a number, that's it. So atomic masses of most of the elements are fraction. As I already said, why it is a fraction? Why it is not always a whole number, 1, 2, 3, 4 like that. So we have 1.08, 1.009, 6.38 like this. But the reason is the element, some of the element exist in the form of isotopes. So average mass should be taken, average atomic mass should be taken. Therefore, atomic masses for the most of the elements in the form of fraction. That is the reason. Atomic mass. So if I write a 15, what it mean? 15 is a number. It's a meaningless. It's just a number. So being it is a mass, it can be expressed in terms of a grams. It is called gram atomic mass. For example, gram atomic mass of hydrogen is 1.008. That is a number. 1.008 grams means gram atomic mass of hydrogen. 4 is atomic mass of helium. 4 grams is gram atomic mass. Gram atomic mass. You are expressing atomic mass in terms of a gram is called gram atomic mass. So atomic mass of an element is related to equivalent masses. This is a totally different topic. It will be explained later. Equivalent mass calculation is different, but this formula you should know. We are using to calculate a empirical formula in the next sessions. So atomic mass is also be calculated using equivalent mass and valency. See, I will explain in brief the meaning of valency. Valency is a combining capacity. Combining capacity. You take one atom. If you take this atom combines with how many other atoms or how many bonds can be possible to form with other, this tendency of bonding is considered to be a valency. This valency is taken to determine atomic mass if you know the equivalent masses. This is a different one, it will be explained further. Okay, one, fine. Next is 1 gram atomic mass. See, 1 gram atomic mass is different, mass of one atom is different. Many of us will get confused over what is the meaning of 1 gram atomic mass. We calculated mass of one atom, mass of one molecule. Here it is different. So 1 gram atomic mass of an element. So 1 gram atomic mass is nothing but it's a gram atomic mass. Gram atomic mass. So which consists of, if you take a gram atomic mass, which is nothing but Avogadro number of atom. For example, what is 1 gram atomic mass of hydrogen? Only one. 1 gram atomic mass of helium, 4 grams. You take 4 gram, which is equal to 1 gram atomic mass, which is equal to 6.022 into 10 to the power 23. If I use 1 gram atomic mass, which is nothing but gram atomic mass of a substance, instead of gram atomic mass, they will give like this. 1 gram atomic mass can also be given. Don't get confused. So mass of one atom, mass of one molecule is different. 1 gram atomic mass is different. 1 gram atomic mass. 1 gram, in simple words, 1 gram atomic mass is equal to its gram atomic mass, which consists of Avogadro number of particle. Okay. So using this, we have calculated mass of one atom, mass of one molecule, mass of one molecule. So this is about atomic mass. See, we have not discussed all these things in the last class. I gave a brief note on atomic mass, mass number, and also how to calculate average atomic mass for different isotopes, taking chlorine example and carbon as the example in the previous class. This is about atomic mass. Now, related to that, let us discuss some numericals. An atom of an element weighs 5 into 10 to the power minus 28 grams. Calculate its atomic mass. This question is related to the formula what I discussed now. What data is given? So data is given, mass of one element is given. First you write mass of one atom of an element, 1 atom is equal to 5 into 10 to the power minus 23. Then what you should calculate? Gram atomic mass. Gram atomic mass. See, if a mass of a substance is given, you have calculated mass of one atom. Here, mass of one atom is given, you should calculate gram atomic mass. So, if you want to get gram atomic mass, how many atoms are required? 6.022 into 10 to the power 23 atoms are required. So, if you multiply this number, that is mass of one atom, with the total number of atoms present, it gives a gram atomic mass. Very simple. So, mass of one atom into Avogadro number. Mass of one atom is 5 into 10 minus 23, Avogadro number, which is equal to 30.11 gram. If the gram atomic mass is given, is it possible to calculate mass of one atom? Very simple. Gram atomic mass divided by Avogadro. So it's a repeated formula, but you know what formula to be used. Okay, fine. Let us take other. See, the graphite present in the pencil. Usually we use the word lead, but it is a graphite present in the pencil. Graphite is nothing but a carbon. So we think, oh, graphite is given. Which is that element? No, it is one of the allotropic form of a carbon. It exists in the form of a graphite, diamond. These are nanocarbons. These are all different allotropic form of a carbon. Graphite is nothing but carbon only. Okay. How much? Instead of giving a carbon, they have given a graphite. So because you should know each and everything, otherwise it is very difficult to solve this type of a question. If you don't know the meaning of a graphite, even you know how to solve, it is not possible to get the appropriate answer. The reason, graphite means it is nothing but a carbon. Very simple. The carbon present in the pencil is 240 mg. See here, the prefix is there. Prefix. What I thought in the beginning, that is milli. M is there, milligrams. So what is the data given? Mass of graphite, that is a carbon. Mass of carbon, it is nothing but a graphite, is how much? 240 milligram. 240 milligrams. Always up to now, see, we have taken only grams. We have not taken nanograms, picograms and deci, deca, hepta, nothing. We have taken only grams because we are expressing atomic mass, molecular mass in terms of grams only. So, but here given milligram. So, what we should do? It should be converted into grams. So, let us go to first chart. See here, milli. Where do you find milli? 10 to the power minus 3. 10 to the power minus 3 is milligrams. So, in the place of milli, why I am showing that chart means repeatedly I am telling you, you should be familiar with prefixes, mass number, atomic number and formulas, what I taught you. Milli. Okay, 240 milligrams. 240. So, what is a milli? Again, you see 10 to the power minus 3. If it is given micro, you should take 10 to the power minus 6. So, in the place of milli, what should be taken? 10 to the power minus 3. In the place of m, you have written this grams. 10 to the power minus 3 is nothing but 240 divided by 1000, which is equal to 0.240 grams. 0.240 grams. So, how much mass of carbon we have? 0.240 gram. What should be calculated? So, calculate number of carbon atoms present. So, here gram is there. So, what is our aim? Number of carbon atoms present in 0.24 grams of carbon. So, how to calculate? First is, it is possible if you convert mass into moles. If you know the moles, we can convert into number of atoms or number of particles very easily. Whatever is there is given it should be converted into moles. If number of moles is there, easily we can calculate. Here moles are not given, mass is given. The first step is to be converted into number of moles, and number of moles into atoms. So we can use this formula. So how we know that 12 grams is nothing but gram atomic mass of carbon, or 1 gram atomic mass of a carbon. 12 grams consisting of 6.022 into 10 to the power 23 atoms. How much grams we have? 0.240 grams contains how many? Just cross multiply. So we get 1.204 into 10 to the power 22 atoms of carbon. So I think now it is clear to you what is the purpose of converting 240 milligrams into grams. The reason here we are taking a standard 12 grams, not milligram, not kgs. Even it is given in a micro, we should convert into gram. The reason we are expressing mass, atomic mass, molecular mass in terms of a gram, hence we are converting milligrams into grams. So we get the answer. Okay, so this is how we can convert mass into moles into number of molecules and atoms. So this is about atomic mass. Later I will take up molecular mass, formula mass, percentage composition and empirical formula in the next session. Thank you.